Hi class, let's take a look at example 3. And in example 3, our expression is simply a squared minus b squared, and let me rewrite them with parentheses. So this will be a squared minus b squared. And then we have to be very careful here because your value of a is going to be -5 and b is -3. So I'm just going to put the parentheses. This is -5 squared minus -3 squared, or 25 minus 9, which is going to give us a 16. And that's it for this one. Once again, we just have to double check what's the given expression that they want us to evaluate the terms. Let's move on to problem 4. Now, problem 4 is a little bit more complex because of the format that it's given with the parentheses already there. So I'm just going to say that this expression is equal to 5 times a minus b squared, and then I'm going to put another set of parentheses on the b's as well. At this point, we're going to plug in the values. So 5 and a is 0, so 0 minus a -3 and then squared, or 5 times 0 minus, and then if we exponentiate the -3 to the second, that's going to give us a +9. I'm just going to put it with the parentheses there to emphasize that we're doing the exponent first. Next, let me drop the parentheses, and this is equivalent to 5 times, well, just 0 minus 9, or 5 times -9, or in this case, -45. That's our final answer, and that's actually it for 4. Let's move on to 5. And then 5, we have to be very careful with what's given here because you have one set of evaluation, another set, and then notice that there's no z. What this means is that you're just going to keep the z as a variable. So this is equivalent to, and let me put the parentheses for the x's, x minus y times x plus 2 times y, and then don't forget the z. And then what I'm going to do next is evaluate into the x's the values of 1. So this will be 1 minus your y. Actually, wait. You're only given the x's. We're not given the y's or the z's. B is not in the expression. So in this case, this is just going to be 1 minus y times 1 plus 2 times y, it's not given, plus z. So for this expression, we just have 1 minus y times 1 plus 2y, and then plus the values of z. So this is one way to express it. And let me just double check. We don't have y's. So there's no y's given. We have the value of b, but b is not given in here. So a little bit of a trick question on this one. You're only plugging in the x's. And this would be our final answer. In a later set of problems, they're going to carry an expression like this further. And let me just show you what they would do then. So you technically use the FOIL method and distribute the 1 to these two, the -y to those two, and then simplify it as much as you can. So this will be 1 times 1 is equal to 1, plus the values of 2y, since it's 1 times 2y. Then -y times 1 would be -y, and then -y plus times 2y, this will be a -2y squared plus a z. And this is equivalent to And out of these, you can combine the y's. So you would have 1 plus y minus 2y squared plus z. They may also want it in descending order for later answers. So that means that we're putting the ones with the highest exponents first. So in this case, negative 2y squared plus a y plus 1 plus z. And let me put the variables. Negative 2y squared plus a y plus z plus 1. This is just another way that another answer could be asked at the end of this section. And this is for us to undo any set of parentheses. In this case, these parentheses, and express it in this format. Let me just double check the final answer. So we're looking at 1 minus y, and then 1 plus 2y plus z. So this will be 1 plus 2y minus y. Okay, we're good. So this is our final answer for this one. Remember that evaluate means to plug in into an expression given values. In this case, we're not using the b.